Good morning. Eh, Welcome you all in my class. Today I will teach you about stereochemistry, which is a part of our syllabus in organic chemistry. And myself is Dr. Srirupa Banerjee, and more precisely, I will teach you today is about conformation. Now, what is conformation? To know about the conformation, first we'll have to know some terminologies. So, first of all, I want to tell you about some terminologies. You all know about Newman projection formula, and if we draw Newman projection formula of ethane, it will look like this. And after uh, fixing this front carbon, if we rotate the back carbon, then the structure will be like this, and that is this hydrogen goes over here, this hydrogen goes over here, and this hydrogen goes over here, like this. And then we will see, if we rotate more, then we will observe this type of conformation, and we will now we will know about, we know that this is a this is again a Newman projection formula of ethane. And now what is the difference between these two? This is the staggered ethane, and this is the staggered ethane, and this is the eclipsed ethane. Now, first we know about the term conformation. Conformation is innumerable arrangements of the atoms in space that result from rotation about single bonds. Now, the conformational analysis. A study of physical and chemical properties of a compound in terms of various conformations are known as conformational analysis. Conformers. Conformations of minimum potential energy are known as conformational isomers or conformers. Now the terminology, eclipsed and staggered conformations. If we consider ethane molecule and the Newman projection formula of ethane, then we can consider this type of conformation, and this conformation is termed as eclipsed conformation. In this conformation, CH bonds on front carbon eclipse the CH bond of back carbon. And again, this circle is meant that front carbon blocks the back carbon. Now this one is the staggered ethane. CH bond of the front carbon are maximally separated from the CH bond of back carbon. So this is the staggered conformation of ethane. Different types of conformations mainly arise due to van der Waals repulsion force, though it is too small to account for, and interaction of the electron clouds in the CH and CC bonds. Now, if we consider the potential energy curve of ethane molecule, taking the potential energy in the y-axis and dihedral angle in the x-axis, we will know about the conformational analysis of the ethane molecule. Now, if we start from this eclipsed conformation of ethane and we rotate this back carbon, keeping the front carbon fixed by 60 degree, we will get this conformer, which is 2 here. And again, when we rotate this hydrogen, then we get this, and again this hydrogen can come over here, this hydrogen can come over here, after that here, and again 1 and 7 are identical. So this 1, 3, 5, 7, they are termed as eclipsed conformation, and that is 1, 3, 5 correspond to eclipsed conformation, and 2, 4, 6, they are in the energy minima position, corresponds to staggered conformation. Now this one is staggered one and this one is eclipsed one, and the energy barrier to rotation in ethane is about 3 kilocalorie per mole. As shown here, the difference of energy, potential energy, between eclipsed and staggered is 3 kilocalorie per mole. Now, if we consider the conformation of N-butane, then we can start it from this eclipsed conformation, and if we rotate this back methyl group by 60 degree, by 120 degree, by 180 degree, by 240 degree, by 300 degree, and lastly by 360 degree, we will end it up with the same structure. Now, this one is known as eclipsed, fully eclipsed conformation, since two methyl groups are in eclipsed position in this one, and in 2, since two methyl groups are in 60 degree dihedral angle relationship, this conformer is known as gauge conformer. Again, number 3 is a partially eclipsed conformation, and structure 4 is anti-conformation, since both CH3 is in 180 degree dihedral angle relationship. And number 5 is again partially eclipsed conformation, and number 6 is gauge conformer, and number 7 is identical with 1, which is fully eclipsed in nature. So since these two are fully eclipsed conformation, so they are in the highest energy, they are of highest energy, and partially eclipsed conformations, these 3 and 5 are followed by 1, they are less energy content than 1, but they are eclipsed conformation, so they are higher in energy than staggered conformers. Now 2 and 6, these two are of same energy and they are staggered conformers. They are staggered conformers, and number 4 is anti-conformer, and this is of lowest energy. Now, what about these two staggered conformers? What is the difference between these two energy of these two staggered conformers? That is, what is the energy difference between gauge and anti-conformer? Gauge and anti-conformer, the difference of energy is 0.88 kilocalorie per mole. That is the difference between gauge and anti-conformer. and the difference between in energy between 3 and 4, that is partially staggered and partially eclipsed and anti-conformation uh, are 3.6 kilocalorie per mole, and the energy difference between fully eclipsed and uh, anti-conformation of N-butane is 5 kilocalorie per mole. Now, from this conformational analysis curve, we are um, very easily um, understand about the energy content of uh, eclipsed conformations and staggered conformers. Now, uh, gauge, scene, and anti-conformations. Scene conformations, when the dihedral angle is 0 to 360 degree in butane, 0 or 360 degree in butane, the two methyl groups are in close proximity with the molecule. Therefore, potential energy is highest as shown in our potential energy curve, and dihedral angle is 0 degree as shown here. This is a scene conformations, scene conformations. And what about anti-conformations? The most stable conformations of butane is known as anti-conformations. The potential energy of anti-conformation is lowest since two methyl groups are farthest away from each other in the molecule, and dihedral angle is 180 degree, 180 degree. And gauge conformation, according to previous diagram, butane has three conformers, two of which are mirror image of one another, are known as gauge conformations, where the dihedral angle is 60 degree. You just see the our observation that if we take 2 and put a mirror over here, then we will get 6. So these two are mirror image of one another. So, this is our gauge conformations. Thank you, children. Thank you, students. This is uh, all about for today's class, and we will continue our study in next class. Thank you all.